I've had
So disappointing.
Yeah, the decoding, the first one it was for today, wasn't it?
Yeah.
Yeah, I could look at number 2 and number 3 because now I don't have seminars and things and family members celebrating this and that. And
Okay.
last thing was grandma turning 80. It's almost punishable by death not showing up.
That's true.
Uh,
All right. So to start, some announcements. So the feedback for the class has now its own wiki page. So you can go and add things that you feel should be changed in the course or could be improved. I've got some feedback by emails, so I put it onto the wiki. One of the suggestions was to start lectures on time, and I really tried today to do that, okay? I'm 10 minutes late, and I make all my effort to do this. So it's not that I'm doing it on purpose. I'm just kind of by nature a bit of a late person. So it kind of fundamentally goes into the belief that I don't believe things have to be on time. I have a good story to tell. I was flying from Spain 2 weeks ago or 1 week ago, and I landed, and I had to go by taxi to a train station. And in that train station, I knew I'm gonna be at 11:15, and then the next train where I have to go was at 12:50. Okay, so I have 1 hour 45 minutes of wait to do on the train station. So I arrived by taxi to the train station, and it turns out the previous train was late by 20 minutes. So I jump into the previous train, and I save myself 1 hour 45 minutes of waiting on the train station, right? So next time I'm in the train station and the train is late, I'm not saying, oh man, the train is late by 20 minutes. I'm like, okay, you know, whatever. I'm already 1 hour 20 minutes ahead, right? Because I saved 1 hour 45 minutes from the previous trip. So it balances off. Like you know, I'm kind of open-minded, and sometimes things are late, sometimes things are on time, sometimes things are early. I'm kind of trying to be on time. It's not like the lectures run really late, but I will try to do this. I think it's a good point. I agree with it. It helps with everything, but realistically, yeah, it's hard for me to do this, okay? So I will try. I'm trying. It's not like I wasn't trying before. I was trying. I was really trying today as well. Okay, so that's one caveat. The other caveat is I could put more effort, okay? I could put much more effort into being on time, but it would require me to quit what I'm doing kind of earlier, right? And that also bites into some philosophy of mine, okay? So if I have to, let's say I have to dedicate 10 minutes more before I kind of start everything and come here and spend those 10 minutes preparing and everything. This 10 minutes per lecture, and we have 2 lectures per week. We have 13 lectures during the semester. It kind of ends up, this 10 minutes of every single time adds up to about 8 hours of time, okay? And now the question is, should I put this effort into being on time, or should I use those 8 hours for something else? And my attitude is I use this 8 hours for something else, right? I edit videos, I do I spend more time preparing for this lecture, I edit the slides, I've added some wiki page for this and so on. Otherwise, I wouldn't have those 8 hours, right? I would spend those 8 hours being here and waiting for the lecture to start on time. So there is a cost. It's not like being on time doesn't have a cost. It does. But it has also some benefits, yeah? That is true. Yeah, that's true. So cumulatively, you're right. You have to be here and you have to do something, but you can talk with the tutor, you can work on the assignments and so on and so on, right? So it has cost for me and it has cost for you. I'm not saying it's a wrong point. I'm saying it's a good point. I'm just saying that there are some philosophical unconscious reasons why I'm constantly failing to fulfill that point, even though I agree with it, okay? And I will try my effort to do this. Yeah, there was another hand. Okay, yeah. So yeah, I'm trying. My suggestion is use this time wisely, talk with others, show the code, talk about the assignments. We have to work together on this. I'm trying, and you have to kind of work around my vulnerability, so to speak. All right, so then another point was there was a question on the assignment 2. Twice, two people asked me about the difference between the there is the latest and stop. What's the difference between T latest and T stop? Who knows? What's the difference between those two? Yeah?
Latest is the latest overall, while stop is the latest in the list of tracks currently.
Exactly. So the latest here, I mean the latest is the one which is globally latest. It's the one which the database knows is the latest page, the latest track. And the stop is the one which the current page kind of gives you, right? So when you're paging through the tracks, you have the start and stop, and if you asked for the last page, the start and stop will be, the stop and the latest will be the same. But before that, the stop is always smaller than the latest. So you know you can ask for more. You can ask for more. Now you cannot ask for more because you know you reach the end of the paging, right? Make sense? So it is kind of, and if you're doing consecutive queries, if you're saying, okay, give me tracks from here to here, and the latest is here, it doesn't mean that if you say now from here to here, the latest can move because new tracks may come, right? So the latest is actually always the latest. It's not the latest that you've asked before. So it is kind of depending on what the database is doing. So that was one clarification. And then the second clarification was with the webhooks. There was, so originally we said once the webhook is triggered, you should return this. But it kind of doesn't make sense if your webhook is Discord or if your webhook is Slack, for example, because Slack and Discord expect a different content, right? They kind of expect something like this. And the body is a string. It's not a data structure, right? So I rewrote it and I kind of encourage you to use webhooks as Discord webhook or Slack webhook, in which case you will be returning a string. And the string will be sort of like, okay, the latest timestamp was this, 2 new tracks are those, and the processing took this. So you will include the information that you would normally include as a data structure, but you will format it as a string. And then your Discord channel or your Discord bot can display it on the in the system for humans to read, right? If you want to write your own consumer for your own webhooks, then you can use something like this. But most of you don't want to spend time writing your own webhook consumer. You want to reuse a webhook from Discord or something else. Then this format depends on what the consumer wants, right? It's not for us to specify. It's the specification of the consumer of the particular webhook. Again, does it make sense? So it's up to you. I think Discord and Slack should be fine with just content like this, but you have to check the specs, right, of the webhook that you're using. Do you have any other questions about assignment 2? All right. So what I will do, I will talk a little bit about crawling, web crawling, because that was the code challenge for today. So we had additional task, which was to write a simple crawler, which would check a web page, starting from a particular web page, try to navigate through links, and kind of extract all the resources which looked like IGC files. So I will first I will commit my code. So let's see. Where did I put it? Yeah, so it's here. So there was one submission which I got. There were I'm sure there were 2 submissions, but I don't remember the first URL. Someone sent me either email or direct message, and I couldn't find it. So if there is a person who did submit the challenge, then please send me the URL. But for this one, I have the repo. So crawler IGC. So let's do okay, so I just clone this. Okay, so crawl. So the idea was to write a simple HTML test case where we can where we can see how the crawler does, starting from the index page and then navigating through the pages. So if I go HTML and say Python 3 module HTTP server, I can serve that directory and watch on the localhost 8000 that website. So there is one resource IGC. Go to the next page or next page. So there is 0 and 1. I go to this one, and there is another resource, Anchor, and I can navigate. I can kind of click through the web pages and extract the IGC files, right? So for example, here I see, you can see at the bottom there is a URL to the IGC file. So then I will try to build this. So let's see, what dependencies do we have? Yeah, so let's go mod. What was the project called? Crawler challenge. Go mod tidy. It will download all the dependencies and prepare the project to be built. And I can say go build. And now I should have the crawler. I haven't done it before, so I haven't seen the submission for that challenge before. Okay, so if I call it, and hopefully it takes parameters. Yes, great. So the idea was that you can pass. Yeah, it already uses the default, so I don't need to pass it because I am under the default web server. So I kind of run it, and it says it visited 5 URLs. So the website actually has 5. So 1, 2, 3, 4, 5, and then it found 4 resources. I don't know how many resources were. I would have to check how many actual resources are inside. And you can see there is a weird-looking check for index with multiple hashes, multiple slashes. Okay, so the other thing I can do, I can run this crawler on my data set. So I have my own test case. So if I go IMT HTML, not crawler, HTML. And if I serve my website, it's a little bit different than this one. Similar concept. Okay, it caches. So I have some text which looks like IGC files. So if someone was doing regular expressions, that wouldn't work. I have lots of links back to myself to test various URLs. I can show you in the source. So if I go, oops. So if I go to index.html, you can see that I'm kind of testing various links to the same URL using kind of a slash dot or slash slash notation. So all those URLs are kind of pointing to the same resource depending how you interpret it. So usually we ignore the, so if, for example, if I try to do this in the browser, and if I say slash 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 index.html, I kind of get to that page anyway, right? So this resource should point to the same resource as this one, and it should be only searched once because it's the same resource. So I'm kind of testing if the crawler kind of does this correctly. And then I have the actual IGC URL. So I have href to a particular IGC. And then I have, again, a menu to kind of do a circular thing. So the very first time I wrote kind of a crawling, it was going in circles because it was not recognizing that the resource is the same as before. So you have to kind of do it cleverly. So I can test, I can go and call the crawler now on my website. And my website has 8 pages. So it's 1, 2, 3, 4, 5, 6, 7 pages. And it has 10 resources, 10 IGC resources. So if it works, it should return correct results, visiting 7 pages and 10 resources, but it crashes. So is the person who submitted it here? Yeah. So can you check? Was it crashing when you were testing it on my website as well? It works on my machine. Okay, that's a very good quote. Okay, so I don't know why it crashed. When I tested, I found 5 resources. Okay. For some reason there is a... So why it might be crashing? Might be to do with different versions of the libraries I'm using, because I just pulled the I just pulled all the dependencies, so we might be using slightly different dependencies. Can you refresh and build again? And you're running on Windows or on which? On Linux? Yeah, we can investigate it. You can investigate it after. So I just want to talk a little bit about the crawling, okay? So with the crawler, you have, so with the particular web page, you have some text, and then what you're really after is you're really after the nodes, which are the URLs, right? In this particular scenario, what you're finding is the A nodes, and you want to extract the href, and then if the href ends with IGC, you assume, okay, it is probably pointing to an IGC file. That was the task. And when you start with the page, you have a single page, so you find all the hrefs on that page, and then you have to find all the links from this page to follow-up pages, right? And as we see, we have lots of links here. So I am finding all those links, and then I have to see if this link points to something that I've already visited or that I haven't visited yet. And the way I'm doing it is I have a map which puts into the map all the visited pages, and then if I get a page to visit, which I put into pages to visit, I check if I've already visited it or not. If I've already visited that page, I just remove it from pages to visit and I do nothing. If I haven't visited it, I remove it from pages to visit into visited pages and follow this process recursively. But as you've seen with these tricky URLs, how do I know that this page is the same as this page? I mean, lexicographically, they are different. So originally, when I wrote it, the map was treating them as different. So how would you do this? How would you treat this the same way as this? Yeah?
Maybe you could load all the pages and then compare the contents of them.
You could, yeah.
And if they're the same, you will not go further on that crawling.
Yeah, that's right. So that's a good idea. Why this idea is wrong?
Because it includes a lot of processing.
Yeah.
What we could do maybe is like compare the postfixes of the paths itself, because the postfix is index.html for both of them.
Yeah.
So
you could compare just the final part, yeah, right? But then that wouldn't work if I have /something /index and /index, right? Then it wouldn't distinguish those two pages. Yeah?
you could compare paths and actually parse the paths, so you know the absolute path for all pages you have visited.
That's right. So first, why comparing content is not the best idea? Yeah? You have to load the whole pages, and also when you loaded a page, sometimes you have some sort of a dynamic content. You may have time, or you can have some count, you can have something which will make those two pages appear different, but they're actually the same page, right? So you would have to account for that. So I did follow the last suggestion, which meant I would have to somehow manage the paths. And you have two ways of doing that. So one way is there is a call on URL which is called resolve reference, and you give it a base URL and you give it potentially a sub URL, okay? And it will resolve to the correct sub URL of that URL, okay? So what it will do is it will, for example, if I pass, because I know my root is localhost 8000 /, right? That's the kind of root. And I started with, so when you pass the, so again, if I do, we're using this one as the main base URL, okay? And then if I use this as a base and pass it this one, it will return me the same URL because it's the same URL, right? If I pass this, it will also return me the same URL, so it's fine. If I pass this, it will also return me the same URL because it knows that multiple slashes resolve into single slash, and it's kind of combines this. It would not work. It would kind of work for this. It does this correctly as well, but it doesn't do this correctly for some reason. So it sort of doesn't know that going one level down, and one level up results in the same resource. So for this one, it wouldn't work. What it would return me for this one is a/a/index, which is different than /index, right? So I have to combine it with something which is called clean, which is on the path of the file system. So as you see here, it really looks like navigating a file system, right? If I do cd a/aa/:/index or something, you know, the path in the file system would know it's going up 2 levels and down 2 levels and it's the same level, right? So it actually cleans all this mess automatically. So I'm using two tricks. I'm using the path to clean up this first, and then I'm using the URL cleanup to clean up the actual URLs. And you can do that with those two methods. One which is on the one which is called clean, which is just on the paths, and actually it doesn't take a path as a type. It takes a string which it treats as a path and cleans up all the slashes and all the folders, if, you know, as if it was kind of a clean path. And then once I have this, I parse it into the URL, and then I do this resolve references to clean it up. And therefore my my crawler kind of deals with those with all those tricks. Okay, so what else is tricky when trying to write this crawler? And by the way, this took me like 4 hours to work out, right? Like now, once you know what to do and which two calls to use, you can do it in like 10 minutes. But to discover those two calls, it took me ages. It wasn't obvious from reading the API that those calls are there. First, I started cleaning up myself manually, but it's a lot of work because you have to deal with a lot of cases. And then I found a bug report which was reporting a bug of dealing with those cases in the actual Golang package. And because of this bug report, I found what method actually implements all this cleaning up. And then I discovered the API, right? So it took me really long time to do this. Okay, so the other thing is, if I have normal web pages like this one, where I have some text, I have some URLs which I can find, and then I have links, it works. But what if I have a JavaScript which has a href, but it doesn't have the href in here? It adds it when the page opens, right? So if I navigate into my page 0 and then navigate to page 1 and navigate to page 2, there is a hidden IGC which now links to the IGC file, right? But in the HTML, it doesn't. In HTML, I only have this. I don't have the href actually here because this is dynamically added by the JavaScript when the page loads. Therefore, if when I'm scraping this, when I loaded the HTML into my crawler, I will not see this href, right? But in the browser, I do. What's the difference? The difference is that the browser runs the JavaScript, and it actually fills that href for me, right? And it is here. But in the original page, it wasn't. So the normal scraper, if you use the Collie library, which I did initially, would miss that. It would miss that hidden IGC file, right? So same as Anders. That's your name? Yep. He actually suggested using Chrome DP, which is another package which runs the Chrome browser for you and loads the page into the Chrome, and then you can check what the page looks like. So we've been doing that. We've been actually loading the HTML text into the browser, either with the view with the UI or headless, without actually seeing the browser, and then checking what is visible on the page to get all those IGC files. So I have the trick which was hiding this IGC file, and then I had another trick because, as you see, the link to page 3 is also generated, right? So originally you would get stuck on this page because you wouldn't see the link to page 3. But because we run the page in the browser, we can see link to page 3, right? You would potentially, if you were doing regular expression scraping of the actual text, get this text, and it looks like a HTTP resource, right? You could use that from the actual JavaScript text, right? And you would also see this, and this looks like a relative URL from the current page, right? So you could potentially scrape those two things even without doing any JavaScript tricks, just by doing regular expression on the page. But then I had another thing which I've used in page 4, where those things are not scrapable anymore because JavaScript does some operations, right? So you cannot see the actual URLs as text, right? So you see some operations like, if you were searching for something which starts with HTTP, followed by the host, followed by the resource, this wouldn't find it, right? And the same here. If you were finding some pages, you wouldn't find it because there is some JavaScript logic which kind of generates the actual text, right? So you really need to run the JavaScript to discover that one. So that was the second difficulty. And then the final difficulty was, even in the browser, you don't see the actual links. The user has to click to enable page 5, and the user needs to click to enable the URL for the resource, right? So you need to click on the click here things. So for the user, for the human, it's easy to find those two things, but for the automated scraper, that's nearly impossible, right? So how would you solve this? With the Chrome DB, you can click on things, but which things you should click on, right? There is a lot of things you can click. Obviously, you should click. So if you look at the and this one, in the text, you have to have on-click handler. If you don't have on-click handler, there is no point on me clicking on something, right? But if there is on-click functionality, I can click on it to enable it, to kind of trigger it, right? So what I can do is I can search on the page if there are any elements which have on-click handler and only click on those, right? But that creates a very complex pathway, because imagine you open the page, and now let's say, like in this case, you have two things you can click on. In this case, the page actually doesn't go somewhere else, but if you had a click event which leads you somewhere, you have to remember that, okay, from this page after this click, this happened. So then you have to have like a combination of different clicks and different events that happened afterwards. So you have to keep track of this. So you have to keep track of what happens if you clicked on this, what happened if you clicked on this, what happened if you clicked on those in different order, and what happened on the page if you clicked on both in different order, right? So yeah, I haven't implemented all of it. I only implemented the one clicking on the first thing that I found, and that enables the next page. And then from the next page, I got the resource. So I was not able to find all the resources, but I was able to find almost all but one. If I implemented the logic of clicking on everything consecutively, then I would find it, right? But you can see it's a little bit complicated to do that in kind of a good way. And Go does support you. They allow you to do clicking on things. There are some caveats. So for example, using Chrome DB is not that easy. You have to search for the various elements, and you have different ways of navigating. What are the typical ways of navigating kind of elements in the HTML DOM tree? Have you used CSS or have you used something? So how do you tell CSS that this particular element needs to be read, for example? What do you use? You can use ID, or you can use a class. What else can you use? Yeah, you can also say like an element like P, this exactly. So you can specify a path, right? You can say what is the path for a particular formatting, right? So you can play with it in the browser. If you go to developer tools, yeah, not in this browser. Yeah, in this browser probably as well, but it's better with Chrome. So if I go to Chrome and go to my page and go view developers tools, what I can do is I can specify Control F, and here I can start searching for yeah, this one is a little bit So the idea is that you can, yeah, yeah, that's better. It's a little bit tricky to organize it in such a way that you can see what I'm doing. So if I start typing, for example, A, it selects all A nodes in my DOM, starting with the first one, and it tells me how many I have, right? So it says, okay, your first A element is just here, and then you have 5 more, and I can kind of see where they are, right? In the same spirit, I can say which elements have on-click handler. So I would say which on-click, which elements have on-click attribute. And then it says, okay, there are 2 on this page. The first one is here, and the second is here. And using this, you can kind of try to find out which paths you have to use to get to a particular node. So when you are dealing with those paths of what to specify, then you can use the browser to kind of help you define them. So here I'm saying I want all P elements which have on-click attribute, because that's what the page had. The problem was, if it doesn't find it, it will crash. So I can only do this on pages which have those elements. So in fact, I would have to try to find all the nodes that have this element, and then call the rendering of the page and kind of doing it. So I use a dirty hack because I know only one page has it, and I kind of hard-coded it here. So it's kind of cheating, because normally I don't click on things. I only click on things for that one single page. So the code is quite straightforward. The basic idea is with those 3 data structures for storing things. Why do you think I use maps instead of using a list for storing pages to visit, for example, and for storing visited pages? Would the list make more sense? Saying, okay, put this into the list and then take it out of the list, for example, for pages to visit. What would you use? I'm not mapping anything to anything. Like, it's just a string, right? It's the pages to visit is just a string. So why I'm using a map? Yeah? Exactly. So if you use the list, which I did, initially I just used a slice of strings. But then, you have to say, when you do la la la, if you do, where is it? So where is my code checking for? Oh, come on. Oh yeah, it's here. So in here, I have to check. So if the URL, if the href has the ending IGC, I just put it into the found things. But even then, I have to check if I already have it. If I already have it, I put it. I mean, if I already have it, I do nothing. But if I don't have it, I put it in, right? So here I have to check, do I have it? And if it was a list, I have to go from element 0 to the last one to saying, are you the same, are you the same, are you the same, are you the same? No, okay. Go doesn't have an easy kind of contains method which checks if something is inside the list, right? So it is kind of a drawback of the language a little bit, and it's also a drawback that you cannot have a generic method called contains that would check any slice for a membership of a particular element, because Go cannot have methods or functions which take different types of attributes or of parameters. So in Java, for example, I can have a method called contains, and it can take a slice of strings or slice of ints or slice of floats, because those would be 3 different methods, right? In Go, you cannot have that. So you would have to have a function called contains string, contains int, contains float, contains whatever the actual slice is, right? Because Go doesn't have generics. So it is, yeah, to cut this long story short, it's easier to use map, because with map, I have just one line to check if something is inside the map, yeah?
Can you still do as in C, where you have different functions with the same name, but different parameter types?
No, you cannot.
Oh, okay.
So in Go, you cannot have that. You would have to have different function names, yeah, for different parameter types, which kind of sucks. Yeah, so even in C you can do that, but in Go you cannot. So yeah, in those 2 cases I have to check, have I found the same URL twice, then I don't put it in. And here I have to say, okay, have I visited this page already? If I did, I do nothing. If I didn't, I say, okay, process this page. So I put it into pages to visit if I haven't visited yet. All right, so what we can do is we can, in the break, test the code, and we will, after the break, we will start discussing AWS and Amazon services. And this kind of, yeah, it's, there was no real competition. There was just one submission. So I will, yeah, Anders will get some extra credits for the code challenge. And we kind of, I guess, conclude like this. So, yeah. So let's have a break until 20 past 3. All right. So that kind of digression, like it was a relatively simple thing, like to just navigate URLs, but it ended up being kind of quite challenging. But I learned quite a lot about like limitations of Go, and also some of the more advanced APIs and how to deal with some of the external libraries. All right, so what do we have today? We have to start with AWS, but the concepts are kind of across all the cloud providers. Some things are named differently, almost always. Every vendor has their own naming conventions, and they name things kind of differently. But conceptually, all of them are to provide you the infrastructure for you to run your code on some remote resources, right? So what I did, I will explain some of the terminology and some of the concepts today, and I put some of the resources for Friday for you to check. And yeah, we've already done that. So what's Amazon? Anybody? A company? What they do? Yeah. Yeah, what do they do? In general. Yeah.
Mainly they're a web store, both first, I guess.
Yep.
And then they kind of branched out to
Yep.
different things, including this.
So if I go to Amazon.com, it's, yeah, okay. It's a shop, online shop, right? Do they stream video? Do they have something called Amazon Prime? Yep, they do. Do they have some equipment like for reading books, like called Kindle? They do. Do they have something which you can install in your home for home automation? And yeah, they do. So they kind of do a lot of things, right? They started as a bookshop, right? The idea was that you can buy books online. Imagine how progressive that concept was in the early days of internet. Selling physical books online on the internet. Like, how can you possibly sell physical books on something that is just, you know, digital? Like, internet has nothing physical. You can sell ebooks. That kind of makes sense. But selling physical books, people thought it's just crazy talking, that this concept will never take off, right? So they started selling books on the internet. So what do you do when you sell books on the internet? What do you need? Yep, you need some warehouse for storing the physical books. What else do you need?
Shipping infrastructure.
Shipping infrastructure, yeah. They've built that. What else do you need?
You need servers.
For what? You need an ordering system, exactly. So you have warehouses, you have transportation, and so on, but you need to have kind of a web presence. You need a website, right? You need a website. To have a website, you have to have a server, right? And the website takes orders. And then the servers you have some sort of a database, and it dispatches the orders. It tells, okay, from this warehouse using this truck, it goes over here, right? So you need this. So they've built this, okay? So it was a bookstore selling books, having a website, and having some infrastructure, some servers. And what happens? Well, what happens is that most of the year, you don't need much. You just need one server. But for Christmas and for Easter or some holidays or Black Friday sales or whatever you have, you need more than one server. You need 1,000 servers, right? So when they become very popular, they've not realized that they have thousands of servers to deal with the traffic for Christmas sales, right? Otherwise, they would not manage to deal with the requests. And what happens if they don't manage to deal with the requests? They lose revenue because those are the money in the bank, like every sale gives them revenue. All right, so they built a huge infrastructure for dealing with the traffic during Christmas time, for dealing with millions and millions of requests. And then most of the year, it was sitting there, not used, right? So they say, now we have those thousands of servers. Most of the year, we just need one. What we do with the rest? And they came up with this concept of saying, well, we can kind of rent it. Maybe some other people need some space or some processing power or something, which we have, but we have no use for. So that's how it all started. It started with one company having a lot of resources and not utilizing it in the, in most of the year and only needing it for a particular period of time. And they, initially started AWS by renting some of the unused equipment to people who were paying money for hosting their websites on kind of a virtual infrastructure. And it took off. So all this cloud computing business actually started because of this. And same as with the bookstore on internet, this idea of renting computers also seemed odd. Like, why would anybody use somebody else's computer? I can put my own server and have my own, website on my server at home. But as we are learning in this course, there is a lot of advantages of not dealing with the hardware or infrastructure yourself. So initially, they had something called EC2, and that was basically renting virtual machines. So you can sign up and you can say, oh, I want the server, and they will kind of instantiate a virtual machine for you, and then you can put Linux on it, you can put Windows on it, and you can use it. Same as with OpenStack, right? OpenStack is kind of a next generation of the same concepts kind of done in more open fashion. So that's the fundamental thing. The fundamental thing is you have some computing and processing facility, but you have some other things as well. So we sort of really went quickly through the history. There is kind of an interesting thing I found yesterday preparing for the lecture. So if I do Amazon revenue 2.5 billion, I guess. Was it The Guardian? Maybe it's this one. Yeah, anyway, you can Google it yourself. So if you try to find the Amazon revenue in 2018 in the first quarter, you will get to a figure of about 2.5 billion. How much do you think is because of the actual physical sales, and how much do you think it's because of the AWS, because of the cloud? I will find the link and put it on the wiki, but just from memory, what do you think? Do you think the physical sales are bigger? So like selling all the stuff they're selling, physical with warehouses and transportation and so on. How big is this? And how big is the cloud? The cloud and ad business.
Before or after expenditures?
Net profit, just net profit. How much money they making? So is A bigger than B, or is B bigger than A, and what's the proportion, roughly speaking? So four, 60-30, 40.
I'd say 60-40 the other way around. That's my view.
Yeah.
I would guess it's a lot less for the physical because it's a different market and they're kind of expanding so they can allow themselves to have less revenue. But as for the cloud,
So net profit, right?
yeah. But as for the cloud part, they have their presence, I guess.
How much do you think costs them in operating expenses to do this versus this?
Oh yeah, it's definitely a lot more expensive to do physical shipping.
Yeah, exactly. So by far, this is more expensive than this, right? The ratio, based on the report I've seen, is kind of a 5 to 10 times more expensive to do this than this. And the revenue is close with the B winning by a margin of like 200 million or something. So they both quite close. It's kind of, as you're saying, 60-40 or 40-60. It's actually quite close between them, these two. But the operating expenses in the physical world are much higher than with the digital and virtual businesses. And it is now kind of more profitable for them to run the cloud than to run the bookstore, right? So if they did start it like that when they started, they would have probably made more money rather than selling the books initially, right? Okay, so before we go to here, let's go to the actual Amazon first. And as I said, we're only using Amazon as an example. It's not that we endorse using Amazon. You can use Azure, you can use Google, you can use whatever. It's just that it is the oldest one, it is the most comprehensive one, and it is kind of also the most innovative one. So some services that they offer, others don't offer yet. They will offer it later, right? So if you're kind of following the trends, it's kind of good to see what is happening. So if I go to AWS, and AWS stands for Amazon Web Services. They use those acronyms for everything they do. And most of the time, you can kind of understand what is it about if you know what the acronym stands for. So if you go here, you see they have kind of a number of categories. So they have compute category with the Amazon EC2 being kind of the primary one. And you have all the other things that they offer as services. So just for compute, just for the compute, you have like 12 different subcategories. Then you have storage, database, migration tools, networking, development tools, which is like automation for deployment, and so on and so forth. It's like there is more, and then you can see all of them, right? So it is kind of an overwhelming to just dive into it, but they are kind of a key elements, right? So those key elements we will quickly go through today. So EC2 is the one which it all started, and then there are some others. In the lecture, I will cover those 6 briefly, and there are some other ones, some other important ones, which we don't discuss in the lecture, but you can look it up on Friday from the videos and from the materials that we posted there. So there is the relational database service. Of course, they offer that. They have non-SQL database storage as well. They have their own content delivery network because they have to have stores being accessed all over the world so that you can utilize the infrastructure. They have their own programmable DNS services, so you can programmably control the DNS locations of your servers. Why would you do that? Why would you have a programmable DNS? Yeah. Priorities, exactly. So you can prioritize certain areas and so on. You are more robust against attacks as well. If there is some form of a DNS attack, you can kind of reprogram your DNSs more dynamically than doing human kind of labor. And there is a lot of monitoring services which are built in. So the first one, whoops. Yeah, so the first one is EC2, and that it stands for Elastic Cloud Computing. That's why the 2 is here, because you have 2 C's, some kind of geeky things. So what is it? It's kind of a computing on demand, as simple as that. You can instantiate, as with OpenStack, you've already seen, you can instantiate different instances with different RAM, different I/O requirements, different resources, and the moment you bootstrap it, you can use it, and then you can shut it down, and you only pay for the time it has been instantiated. I don't know the latest charging model. Before they were charging per opened hour. So if you booted an instance, you've already paid for an hour. So it was no point shutting it down for the first 50 minutes, right? And if you booted something, shut it down, booted something, shut it down, booted something, shut it down, it's already 3 hours, right? So don't do that. Like if you need to boot something, kind of think if you have provisioned everything correctly, because if you want to take it down, then if it's on the same instance, that's fine. But if you're bootstrapping different instances, then you will be charged per each open instance, right? And you can, typical optimizations you can use, you can focus on computing power, you can focus on memory, larger memory uses, or storage. How much does it cost? Well, if you're using the cheapest ways of getting the resource, it can be as cheap as about 2 cents per hour, right? So if you think about it, if I need 100 computers for an hour to compute something for me, doing some neural network or something, then it will cost me about $2, right? So some researchers do that. For example, you need to crack some passwords or run some brute force search on some, data set. You just rent 1,000 computers for an hour, you pay $200 and you have your result, right? So it is quite possible that you can achieve something that before was quite hard to do. Like if you have a task that requires 1,000 computers, well, before it was kind of impossible. Now anybody can do it. So I remember when I was doing my master thesis, I was rendering kind of an animation in 3D, and I needed, it was kind of taking about 20 minutes to render a single frame on a single PC, right? And I calculated that, oh my God, I'm not gonna finish by the deadline. So I had to use all the computers which they have in the school, right? So I went from computer to computer. I kind of started like a background batch job, which was fetching what frames it should compute. And then I've used about 100 computers to do that much faster than doing a single computer. And I managed to do this rendering before the deadline. But it was kind of tedious. And if somebody sit in front of this computer and like put the power off and on, I lost my job because the computer rebooted. The good thing was back in the day, all computers were part of the network. We only used Unix-like and Linux-like computers, so they were all multi-share. So they were all kind of connected with each other and talking with each other. So I could log in to any of those running computers and check and get the results. But now I would be using something like this, right? Or could be Amazon, could be Azure. I could start all the rendering that I need. I would instantiate some GPU optimized VMs and have it done in a few minutes and have my result. And I would pay, I don't know, $20 or $30. So it is actually quite cheap to use it. If you have to use it continuously 24/7 for years, of course, it kind of costs a lot of money. But if you have a task at hand, you can do it quite well. So then, if you have a VM, what else do you need? You need some storage. You need to put the operating system on something, right? So there are two types. You can use ephemeral storage. And what does it mean? It means it disappears the moment you kill your VM. the moment you destroy your computing resource, the storage it uses disappears as well, right? So for some things it's okay, like if you have some daemon that needs to respond to some request or something, it doesn't persistently store anything of value, then you can use ephemeral storage, right? But if you have something that you need to store, like I needed to store some rendering frames for the video, then I need to store it somewhere, and even if the machine goes down, that data doesn't disappear, right? So then you have something which is called Elastic Block Store, EBS. So this is basically like a storage facility, right? You have to pay for it. For ephemeral storage, you don't really pay because it's something which is, I mean, you pay for it a little bit as well, but it's like a fixed cost. For this one, you pay per allocated gigabyte that you're using, okay? And it's kind of like a block device. So you mount it, you can use it, and then you can unmount it, reboot your VM, mount it again, and you have all your file systems and everything there. Or you can mount it to another VM. Like if you have some processing done on a very tiny CPU, and you need more cores and more processing power, you can kind of unmount it, you know, create a new VM with more computing resources and mount your file system there, right? So anything that is kind of use on a regular basis, it will be stored on EBS, yeah? No, you can only mount the file system to a single instance. For file sharing, you can use some NFS or some other protocol for exchanging the data, yeah. Okay, so, but then, and that's how it used to be, but you realize that the storage usage is highly dependent on the application of what you're doing, right? So sometimes you need that access to be really fast and on demand with low latency. Sometimes you don't care because you're just archiving your logs, right? So should you pay the same for archiving your logs that are sitting somewhere on a tape and you're not accessing it ever, versus something that you're kind of using all the time? And they realized, well, I mean, it costs them differently depending on you're doing, so you should pay differently as well. So they diversified the offering, and it is actually quite complicated. And the complication is that the offering is kind of quite robust, but you have to do the decisions yourself. So they are not doing decisions for you. You kind of have to decide what to store where, right? So the normal standard storage is the one which you frequently use. It's always available. It has 9.99 availability, but it's quite expensive, right? You can switch to the one which is called infrequent storage, access storage, and that one has lower availability, is a little bit slower to get the data from, but it's cheaper, right? So if you, for example, need, I don't know, once a day you need to get an image of some sort, maybe you can use the infrequent one, right? If you have a 5 seconds delay of getting that image, that's okay. The user will sort of survive, right? But for something more robust and on demand, you have to use the first one. And then you have kind of a glacier type of storage. That's the one where, you know, archiving your logs or archiving your data for, you know, processing once a year. At the end of the year, you have to take all the transactions, do some accounting, and, you know, back it up, right? So then this one is kind of the cheapest, but it takes minutes to get stuff out of it, right? So if you make a request, the data will come, but it may come after a while. You have to wait for the data to become available, right? And then there is this redundancy. So all those three have kind of a built-in redundancy that if there is a hardware failure, you will not lose your data because they have backups of backups and so on, right? The data is kind of redundant. But what if you don't care? What if you say, well, if some disaster happens, I have backup data, so for this data, I actually don't care about the backups because I have the backups myself, right? So then you can use this reduced redundancy storage, which means it doesn't have built-in redundancy. and if something happens, it will disappear, right? So you can check, you know, depending on your use case scenario and depending on what type of data you're dealing with, you can use one or the other, right? And you have different scales. You pay differently for different things. So the more on-demand data you have, the less you pay, and the less redundancy you have, the less you pay, right? So if you need high redundancy, high availability, that's the prime tier you pay the most. All right, so what else do we have? We have virtual private clouds. So what we can do is we can connect our EC2 instances into our own network, and we can have all of them kind of being behind the public infrastructure, public internet. So I can have a gateway which sort of serves the public traffic, but everything else I can have in the virtual private cloud. And the access to it is not, none of those instances is visible from the internet, right? They don't have public IP addresses. They are all kind of within a private infrastructure. And then I may need to monitor what is happening, how the load balancing works, whether I do have some intrusions or not. So there is a lot of monitoring that needs to go in, same as with the normal infrastructure. So like in the university here, we have the servers, we have the cables, we have the switches, we have the routers, and we're kind of dealing with the infrastructure. And most of it has public IP addresses, but some of it doesn't. So we can kind of model the same thing with the virtual private clouds. And the two typical use cases for flow monitoring, for NetFlow-like monitoring, is checking the performance. Do we need more resources? Are we okay with the resources that we have? Are we underutilizing some servers, or are we overutilizing some servers? And security. Is there something wrong going on? You know, do we have some internal intrusions? There are some limitations. Only primary interface is being locked for the flow monitoring. DHCP traffic is not locked, and if you're using the Route 53 internal DNS setup from Amazon, that traffic is not monitored neither. But if you're using your own DNS, then of course it will be monitored. All right, so then we have something called Lambda, which sometimes are referred as cloud functions, or sometimes are referred as serverless computing. It's a recent innovation. It started a few years ago. It's an offering which is kind of similar to Heroku, you would think. It's similar to like platform as a service. You don't care about the scalability yourself. You only deploy by Git or by some other means your code, and it sort of runs, right? So if you think of Heroku, it is kind of like a very big function as a service because it serves multiple functions at the same time, right? It starts the dyno, which kind of serves your request. But if you just isolate, for example, a single endpoint, and you say, I want this endpoint to run as a function, then that would be what cloud functions or lambdas are. So it's, and then your web server is collection of those web functions, right? So on Heroku, we deploy the entire system with all the functions that it has, and you have each function, like you have one Go function per route that you're handling, right? Normally in your code. So you can get this one function, put it as a lambda, and say, if the URL is this, this has to be called. And then it works like the kind of cloud function. So you can use it for in-app development, for writing and executing code, which understands various APIs or various AWS services, which deals with some incoming traffic, with some database events. You can combine it with S3. So for example, you can have a function attached to particular events happening on your storage. So if the user loads an image, you can have a Lambda function which does some post-processing or some filtering or some checks or whatever it is, right? If the new email comes for the user account, you can have a Lambda function which notifies the user mobile application that, oh yeah, you have new emails, right? So you can kind of organize your logic into tiny pieces and deploy each of those tiny pieces as an individual function. So what's the advantage? Well, the advantage is kind of architecturally you isolating the logic of what is happening into independent components, and then you don't care about the scalability. So the infrastructure provider, in this case Amazon, will take care of scaling. So if you have one request coming, they will probably use just one VM for handling your traffic. If you suddenly have a spike and multiple requests are coming for a particular function, they will scale it such that they can deal with the incoming load accordingly. And you can use the logging facilities and combine it with functions as well. So you can say, I want something to happen when something happens in my system, right? We will talk a little bit more about it later, and we will use one of the Go examples to demonstrate how does it work. From working with it, it sort of feels kind of like working with the minimalistic version of Heroku in a sense, because you just have a single piece of code that you deploy, and it sort of does what needs to be done. All right, so I think we covered the ground. So we went through the list of those 6. No, we missed the load balancing. So ELB is Elastic Load Balancer. So normally what happens is you have a website, like in the case of the bookstore, which takes the requests. And you have one server which deals with the requests. What happens if you have so many requests coming so quickly that the server is not sufficiently strong to handle it on time? There are long delays or things have to be dropped. You have to add another server, and you have to say every second request goes to this one, every second goes to this one. So both will be kind of replying and doing the processing, right? And this is called load balancing. When you have multiple resources dealing with some kind of incoming flows, and you balance how they are utilized, which requests go to where, and you isolate the overloaded resources, and you don't put traffic into them. You put traffic into the underutilized resources, right? So there is a built-in facility which allows you to kind of direct traffic depending on some loads of the resources and scale your infrastructure. One thing to remember is that all the bootstrapping of the VMs and using all those facilities you can do with the GUI. You can do through the through the interface which you have with Amazon. So if I go to here, I can log in and I can manage my EC2 instances and so on. You can do that with the command line tools. So you can use command line tools to instantiate and bootstrap some of the resources, use the storage and so on. But you can also do it programmatically. So obviously, if you have a website and you have to scale it up or down, nobody's going to sit there and start instances like manually. You have to kind of automate it. And you can use kind of programmable APIs to do that, or use some triggers within the Amazon system which allow you to automatically bootstrap some of the resources. But you in charge, right? It is not platform as a service. It is infrastructure as a service. So you in charge of doing all of this yourself, right? Which might be a little bit surprising. So for example, when Amazon has a hardware failure, then it is your job to migrate your stuff from one VM to another VM. They don't do that automatically for you. You have to say, okay, I have to load everything to some EBS storage. I shut down this broken VM, and then I bootstrap or provision new one, and then I get the new one going, and then I move the data to the new one. You're doing it manually, right? It's not automated. So with some facilities, like with Heroku, you don't care. You don't care if they have a hardware failure, like your dyno needs to work, and you don't care where it is and how it runs, right? So that's more like platform as a service. Okay, so I will finish in 1 minute. I just tell you one more thing. And then one more thing is here. So when you ordering the VM, you can say I need a new VM, and then you pay per hour of usage, and that's the highest price you will pay because you're doing it on demand. If you say I will need one VM, next year, then you reserve it, you pay a fee, and then when you're actually using it, you pay very little because the cost of using the VM is already paid by the fee that you did for reserving it. And then when you're using it, it's very little. And then combined, it's still cheaper than on demand, right? So if you know you need a website running for a year, you can reserve it, pay the fee, and then pay as you use it, and it will come cheaper, right? So those are those two modes. So on demand is like, oh, I need a website right now, give me one. And then spot pricing is you say, I have this rendering job to do, but I will wait for a price to be really cheap, and only then I will use it. So you can set up a trigger, and the VMs are kind of traded on the open market, right? Because some people have already reserved a VM for, let's say, 3 years, but they know they're not gonna use it. So if they are not gonna use it, they're gonna lose the fees that they've already paid. So they say, I'm gonna rent somebody else this VM to recover some of my costs. And then the prices being driven by the market, by the people who want to use something and the people who want to sell something, right? In this case, computing resources. So the spot pricing is the current actual price on the market where the price fluctuate. Those two are set by Amazon. So those are fixed, they don't change, and they are kind of the same, and they are guaranteed. This one kind of fluctuates. So sometimes you can get your password hacking done on a very cheap budget if you just wait for the price to kind of reach certain level, right? All right, any questions? All right, so we will finish here. And no lecture on Friday. Just watch the videos and check the online resources. And we will meet on Tuesday.
I have a question about the exam too.
Okay, just give me a second to finish the streaming. So we talk off stream.